Okay, good day everyone. So this will be lesson 6 for the new lesson 6 differentiation rules. So to start, let's try to define some terms. So take note, the process of getting a derivative is called differentiation. And again, when you get the derivative, you are actually getting the change of the function in terms of the slope of the function. So that's why our notation here is dy over dx. So take note, this notation is called Leibniz notation, as we have discussed in our performance check. Uh, yeah, we have answered in the performance check. It's dy over dx for the derivative. Also, sometimes we use this notation, the prime notation. So there are a lot of notations, but these two are the main notations used in academic calculus. So we have the f prime of x and we have the dy over dx. Okay, so for basic calculus, we will only use these two. Then we have the derivative operator. So if you see this, d over dx, it means that you're going to get the derivative of whatever is the function here. Okay, so now let's go to the differentiation rules. So differentiation rules are just shortcuts. So that instead of using the limit definition of the derivative, we just use certain shortcuts so that it's very easy for us to solve. So mathematicians have listed many shortcuts throughout the centuries. These are just patterns observed that whenever you solve using the limit definition, it always come up with these certain patterns or rules. So let's have the first one. So for the first one, we have the constant rule. So when we say constant rule, so for example, you're given with a function in which the function only contains a constant. So let's say c here. The derivative is always 0. Okay. So example, find the derivative of y equals 10 with respect to x. So instead of using the limit definition, the limit as h approaches 0, f of x plus h minus f of x over h, we can just directly give the answer because there is already a rule for that one. So we have our dy over dx. So the derivative of our function y, is actually 10 here. So that's why it's dy here. Then it becomes d over dx 10 here because of the derivative operator. So we just put the answer as 0, and that's the final answer. So again, any constant, as long as it's a constant, it's automatically 0. Next rule, we have the power rule. So the power rule states that if you have a pattern in which you have a variable raised to the power of a constant n, so it's x to the power of n in this case. So our derivative is just this. We have n x to the power of n minus 1. So it's like the n here in the power or the exponent becomes the coefficient here. And then our exponent here is subtracted by 1. So example, find the derivative of y equals x squared with respect to x. So again, we have dy over dx and the derivative operator of x squared here. So what happens that our 2 becomes the coefficient, and then we have x to the power of 2 minus 1, which is just 2x. Okay, you don't need to write 1 here anymore because x to the power of 1 is just x. So the final answer is just 2x. Okay. Next, we have another example. So what if there is a coefficient already in your function? So we have here, find the derivative of y equals 5x to the power of 4 with respect to x. So what happens here is that 5, because it's just a constant multiple So we can actually multiply 4 here to 5. So that's why we have here 5 times 4. Okay, so again, multiply the exponent to the coefficient here. So we have 5 times 4. And then, of course, subtract the exponent by 1. And you will get 20x to the power of 3. So it's still the same pattern, but instead of uh, having 4, just 4 here, you multiply 4 to 5. And then last for power rule. So what if you have a rational function like this in which the numerator is just a constant? There are no variables in the numerator, but the variable is in the denominator. In this case, we have 3 over x to the power of 4. So, uh, remember, in your GenMath, in your functions, you can actually change this. Okay? You get the reciprocal and the exponent becomes a negative exponent. So if you have, for example, if you have 1 over x squared, it is actually just x to the power of negative 2. So that's what happens here. So we have 3x to the power of negative 4. So we can now apply power rule because we have x to the power of n here. So just like the previous example, we just multiply negative 4 to 3. So that's why we have it 3 times negative 4. And of course, subtract 1 to the exponent of the variable. So this will give us negative 12 x to the power of negative 5. Okay, so we need also to return it back into its fraction form because we cannot have a negative exponent. So that's why here the final answer is negative 12 over x to the power of 5. Okay, let's have the next rule. So we have the sum and difference rule. Basically, the sum and difference rule or difference rule just states that we can get the derivative of each term. So if you have multiple terms in your function, you can divide it into different terms, different derivatives. So example, we have here y equals 3x squared minus 2x plus 1. So instead of solving it in one go, we can actually divide. So we just get the derivative of 3x squared, then derivative of 2x, then derivative of 1. So that's why here we can rewrite this one as derivative of 3x squared minus derivative of 2x plus derivative of 1. So you'll get the derivative of each term. That's the simplest explanation for this rule. So the derivative of 3x squared, so take note we have 2 times 3. So we just multiply the exponent to the coefficient here, then minus 1 in the exponent. So we'll have here this 3 times 2x to the power of 2 minus 1. Then of course, we have 2x here. Take note, the exponent of x is 1. So that's why we have here 2 times 1. So the signs, by the way, are just carried over to the next step. So we have 2 times 1, x to the power of 1 minus 1. And of course, derivative of a constant is 0. So that's why we have here plus 0. So if we simplify, this will give us, of course, 0. This is 0. And then x to the power of 0, 2 times 1 is just 2. So x to the power of 0 is 1, which is just, we have 6x minus 2. That's the answer for this one. So by the way, you don't need to show everything for the solutions. You can just actually answer this one directly because if you try to do it mentally, it's very easy. So 2 times 3 x, so we have 6x minus 1 the exponent, so we have 6x here. Then just get the coefficient here kasi x, this is just x. So 2, then of course 0, the constant is just, derivative of constant is just 0. Okay, next, what if you have multiplication? So if you have u times v, so let's say you have u and v as functions. So we have here the pattern u dv plus v du. So you don't need to remember the d over dx. Just remember that it's just u dv plus v du. That's the pattern. Okay, so how to solve? So let's have an example. Find the derivative of y equals to x plus 3 times x plus 4. Okay, so basically, we can say that this is the first term is always u, the second, not term, but factor. The first factor is u, the second factor is v. That's the pattern, because it's the pattern here, u times v. So, we can say we let u be equal to 2x plus 3 and v be equals to x plus 4. Then we have, again, the formula is u dv plus v du. So, we just substitute. So, our u is 2x plus 3. So, again, this is our u. Then we have dv. So, v is x plus 4. Okay, plus v, this is v, x plus 4. Then we have du. So, 2x plus 3 here. So, we just need to get the derivative of this, x plus 4, and this, to x plus 3. And then we simplify. Okay? So, the derivative of... Okay, so it might not be very obvious. The derivative of x plus 4, so x is... This is just x. So, take note, the exponent here is 1. So, we have 1 times x to the power of 1 minus 1. Okay, then of course, derivative of 4 is 0. Here, the derivative of 2x is 2 times, it's the same, it's 1x to the power of 1 minus 1 plus 0. Okay, so we'll have something like this, diba? It's 1 times x minus 1 over 2x plus 3 times 1 times x to the power of 1 minus 1 plus x plus 4 times 2 times x to the power of 1 minus 1 plus 0. If we simplify, so we'll get something like this. So 1 minus 1 for the exponent is just 0. And remember, x to the power of 0 is just 1. So we can simplify further. So this is just algebra. So we have 2x plus 3 plus x plus 4 times 2. Distribute 2. And you will get 2x plus 3 plus 2x plus 8. So we can combine like terms. So we have 4x plus 11. Okay. So that's for product rule. I think we still have another given here. So let's have another given. So product rule is actually effective if you have more terms. Instead of just binomial times binomial, you can have trinomial times trinomial. So for example, we have here y equals to x plus 1 times 3x squared plus 2x plus 1. So again, our u is this, the first factor, and then this is our v, the second factor. Okay, so we just follow the formula again. So we write u first before v, dv, then v, then du. So our u is again 2x plus 1, then v is 3x squared plus 2x plus 1, then here v du, so it's the same. So getting the derivative of this, so let's try to answer this in a shorter form without showing the solution. So 2 times 3, we have 6 here, 6, then this is x2 times to the power of 2 minus 1 is just 1. Then here, we have 2, so this is just 0, diba? X to the power of 0, so it's just 1. And of course, this is 0, so plus 0. Here, the derivative is just 2 plus 0. Diba? Kaya you subtract 1 in the exponent, so it's x to the power of 0, so which is 1. So we will get something like this. Simplify further. Okay, and then using algebra, So here we can, in the first part, we can use FOIL here. Have the laser pointer. We can use FOIL here. Then here we can distribute to. So we will get something like this. Yeah, I just repeated it. So something like 12x squared plus 4x plus 6x plus 2 plus 6x squared plus 4x plus 2. And then we combine like terms. So we have here 12x squared plus 6x squared, which is 18x squared. 4x plus 4x is... yeah. 4x plus 6x, 10x plus 4x, 14x. We have 2 plus 2 here, which is 4. So that's the final answer. Okay, so let's have the next and the last rule for this session. So, of course, if there is product, there's also quotient for division. So, we have here u over v. So, if you see u over v, there's a numerator and there's a denominator. The pattern is almost similar to the product rule, pero it's reverse. It's just reverse. So, instead of u dv plus v du, we have v du minus u dv. Then there is over v squared. Okay, so that's the pattern. So, of the uh, derivative for quotient. So, example. So, if we have y equals 3x plus 2 over 2x minus 1, so u will be our numerator, v will be the denominator. So, in this case, our u is 3x plus 1, our v is 2x minus 1. So, using the formula, v du minus u dv over v squared, so we simply substitute. So we have v is 2x minus 1 times the derivative of u. So derivative 3x plus 1 minus 3x plus 1. So take note, don't forget to write also the grouping symbols because this is considered as one group. 3x plus 1 times the derivative of 2x minus 1 over 2x minus 1 squared because it's v squared. Okay. So we can now get the derivative of this first. What will be the derivative of this? So derivative of 3x plus 1 is just 3 because it's 3 plus 0. And for 2x minus 1 is just 2. So we will have something like this. So then we simplify this algebraically. Just distribute 3 and 2. So you have 6x minus 3 minus the quantity of 6x plus 2. Okay, then of course we distribute the negative sign, the minus sign. So you will have something like this, 6x minus 3 minus 6x minus 2 over 2x minus 1 quantity squared. So no need to do some things in the denominator. So it's just 2x minus 1 squared. It's just v squared. So we just need to simplify the numerator. So we have minus or negative 5 over 2x minus 1 squared. Okay, so that's it for this session. Okay, so I hope you learned a lot. Okay, bye-bye.